Christopher Goodbun, and I'm doing a PowerPoint presentation on electromagnetic spectrum. Today we shall be going into principles and properties of types of electromagnetic. I can't.
Carry on.
Electromagnetic waves. Properties of microwaves and infrared using selected examples. The uses and hazards of using X-rays in medical applications. Compare and contrast the properties of visible and UV light. Explain some applications of visible and UV light. And lastly, explain the biohazards of ultraviolet and infrared radiation and their main effects. The principles and properties of types of electromagnetic waves. Here we have an electromagnetic wave. Electromagnetic waves are coupled to time-varying electric and magnetic fields that propagate in space. And did you know that electromagnetic velocity is 300 million meters per second? The human eye has evolved. The human eye has evolved to detect a band of wavelengths in the middle of the range. This is the spectrum of visible light. This is a spectrum of visible light. I wrote that twice. Red, orange, yellow, green, blue, indigo, purple, which can also be known as Richard of York gave battles in vain.
Where they use violet instead of purple.
Sorry, I can't read this.
Just sit forward a little bit and you'll be able to see it on there.
Right. Yeah. Short length equals high velocity. Longer length equals lower frequency. In equations, frequency is represented by the letter F. Wave frequency is measured in hertz, symbol Hz, meaning cycles per second. We also use the term velocity instead of speed. Speed is motion in any direction, whereas velocity... oh no. Whereas velocity is a vector measurement which has a specific direction. The wave equation, these three properties of waves, velocity, wavelength and frequency, are mathematically related by this equation. Velocity is frequency times wavelength. As you can see in the diagram there, you can find out each bit of measurement by the triangle that it represents. The properties of microwaves. Microwaves are a type of electromagnetic radiation with wavelengths ranging from approximately 1 millimeter going up to 1 meter. They have shorter wavelengths and higher frequencies than radio waves, and the key properties of microwaves are their ability to penetrate various materials and their efficient energy transfer to heat. Now, the properties of the infrared light. Infrared waves, commonly known as infrared lights, are part of the electromagnetic spectrum. People encounter infrared waves regularly, although these waves are invisible to the human eye. Humans can detect them as heat, though. Yeah. In comparison to microwaves, infrared waves possess shorter wavelengths and higher frequencies. Therefore, infrared waves can carry more energy than both microwaves and radio waves. Here are some of the uses infrared and Bluetooth microwave use. Orientation. Infrared is a direct line of sight. It will not pass through the walls. With Bluetooth microwave, Bluetooth devices can communicate even when they are separated by obstacles. You can use them for security, which infrared signals can only be intercepted by a device in its line of sight again. But the omnidirectional nature of Bluetooth makes it less secure than infrared, even though protection is coded. Range, should I do all of them? Range, infrared is normally about a meter, but can work at up to 5 meters depending on the environment. Whereas Bluetooth, officially class 3 Bluetooth, works at about 10 meters. Connectivity, infrared devices make one-to-one connections, like the remote control to your TV. Bluetooth devices can form networks once all of the devices have identified themselves to each other. Versatility, infrared devices such as TV remote controls need to be designated for specific devices, whereas on Bluetooth, almost all Bluetooth devices can work together. The hazards of X-rays in medical applications. Diagnosis. X-rays can detect conditions like blocked blood vessels, bone cancer, and infections. Sterilization. X-rays can be used for sterilization without high temperatures. Radiotherapy. X-rays are used to kill cancerous tumours, and X-rays are linked to an increased risk of cancer, though, so it does come with a drawback. The hazards of X-rays. They ionizing radiation. X-rays produce ionizing radiation that can harm living tissues. Right. UV wavelengths are shorter than visible light wavelengths. Visible light has longer wavelengths than UV light, so that's one of the big differences. UV rays can be blocked by the clouds. Throughout hospitals as well as laboratories, UV lights are used to disinfect. Whereas visible light has longer wavelengths than UV light. When white light passes through a prism, it disperses in 7 colours of the visible light spectrum. The frequency of visible light ranges from about 4 times 10 by the power 14 to 8 times 10 to, that's right, isn't it? Power 14 cycles per second, hertz. This frequency corresponds to the colour perception by our eyes. Applications of visible and UV lights. Visible lights enables human vision, allowing us to perceive our surroundings. Artificial lighting illuminates dark areas for us. Communication uses visible light in optical communication systems such as fibre optic networks, which transmit data through pulses of light at high speed. Photography needs visible light since cameras capture light reflecting off objects to create images, and medical applications use visible light in various medical procedures such as laser surgery, endoscopy, and phototherapy. Whereas on the UV light can curing or drying materials such as inks and coatings, disinfection for viruses and bacteria, hygiene and infection control, fluorescent inspection, where they shine a UV light over different objects and you see different colours come up, tanning, sterilisation of equipment in hospitals and laboratories, detecting substances that are invisible under normal light in forensics and astronomy. But the biohazards of ultraviolet and infrared radiation and their main effects. Both ultraviolet and infrared radiation can damage skin cells and lead to cancer. Both also lead to eye damage. Short wavelength light, blue violet, can cause a retinal photochemical burn. whereas longer wavelengths and shorter pulses of light appear to be capable of injuring the retina by a thermal damage mechanism. We have looked at each type of wavelength and radiation that can be caused from ultraviolet and infrared lights. References. I forgot to end.